Hey guys, and of course, hi sir. I hope every one of you have a wonderful day. So welcome to the Group D Business Data Mining presentation for today. And I hope you guys enjoy our presentation. So welcome everyone to the Group D Business Data Mining project presentation. So today our title will be Retail Fraud Detection, Data-Driven Solution. So stay tuned. And of course, before we begin, let's have some get to know who are the Group D members. So first of all, hi, I'm Sharizal, and of course we have Ivana, and we have Shreya, and of course Shijing. Now I'll pass it on to the first group members, which is Ivana, to continue on our project business problem and furthermore information.
Thank you, Sharizal. Now, let's start by looking at the core challenge we are tackling today: unauthorized financial activities. So, from fake identities and payment manipulation to complex cross border scams, fraud in digital finance is becoming increasingly sophisticated. Now, why is this happening? Looking at our contributing factors, fraudsters are exploiting weak authentication systems and outdated login methods. Combined with high transaction volumes, it becomes very difficult for traditional systems to spot bad actors in real time. The impact on businesses is very severe too. Beyond direct financial losses and indirect operational costs, high rate of false positives annoys customers. And worst of all, a brand's reputation can suffer long-term damage. So this is where data mining comes in as our solution. By using machine learning models, we can analyze transactions as customer behavior patterns simultaneously, minimizing false alarms while catching fraudulent activity before it escalates. Now, to tackle this problem effectively, using data, we formulated four key analytical questions to guide our investigation. First, which payment methods are most vulnerable or likely to be fraudulent? Second, what is the exact impact of transaction frequency on overall fraud risk? Third, does fraud risk spike dramatically when high risk devices are paired with unusual geographical activity? And finally, how do specific transaction characteristics directly affect the overall probability of fraud? So, by answering these questions, we can build a data driven defense strategy rather than just relying on guesswork. To answer these analytical questions, we use the Retail Intelligence Fraud Detection Dataset published by BAT 2026 on Kaggle. This is a comprehensive dataset containing over 100,000 transaction records, giving us a solid sample size for robust analytical modeling. Our primary purpose with this data is to conduct exploratory data analysis, EDA, apply core data mining techniques, and train machine learning models. So, in terms of key attributes, the dataset covers four critical areas: customer profile data, individual transaction details, specific fraud indicators, and behavioral data, giving us a complete 360-degree view of user activity.
I will explain the methodology used in this project. Our project follows a 5-stage data mining approach. First is data collection, where we load a retail intelligent fraud detection data into Python. Next is data preprocessing, where we clean a data set, remove unnecessary variable, encode category data, and also standardize numerical variable to prepare the data for machine learning. The third stage is exploratory data analysis. This helps us to understand the transaction behavior, identify fraud pattern, and also select the most important feature. After that, we built 3 machine learning models: logistic regression, random forest, and clustering to predict whether the transaction is fraudulent. Finally, we elaborate the model using classification metrics to identify the best performing fraud detect models. Before training the model, we perform data preprocessing to improve data quality and ensure accurate prediction. First, we clean the dataset by checking for missing value and duplicate record. We also remove transaction ID, customer ID, and transaction timestamp because those variables only identify transactions and do not contribute to fraud prediction. Next, we transform the data. Numerical variables such as transaction amount and transaction frequency were standardized using standard scale. Category variable, including payment method, device type and channel type, and customer location, were converted into numerical value using one-hot encoding. Finally, we're using scikit learning column transformer to apply the same pre-processing step consist.
Hi, my name is Shreyashi Jaikumar and today I'll be explaining the methodologies used for our model building. To address our business problem for detecting fraudulent transaction, we apply two data mining techniques, namely classification and clustering. For classification, we use logistic regression, decision tree, and random forest because our dataset contain labeled transaction data, allowing us to predict whether a transaction is fraudulent or legitimate. Logistic regression served as our baseline model, whereas the decision tree captured more complex decision rules, and random forest improved prediction performance by combining multiple decision trees. For clustering, we implemented k-means, dbScan, and Gaussian model. Unlike classification, clustering groups transactions with similar behavior patterns without using predefined labels. This helps uncover hidden transaction patterns and identify suspicious customer segments that may indicate fraudulent behavior. By applying both techniques, we were able to build a predictive fraud detection model while also discovering meaningful patterns that support fraud investigation and decision making. Up next, to evaluate our models, we use different performance metrics depending on the type of data mining technique. For the classification models, we evaluated them using accuracy, precision, recall, and F1 score. These metrics measure how effectively each model detects fraudulent transactions, while balancing false positives and false negatives. Although the original logistic regression achieved perfect scores, it relied on highly correlated fraud indicators, making it less suitable for real-world deployment. After feature selection, the balanced logistic regression achieved 80.21% accuracy, while the decision tree improved to 84.92% accuracy. Among all the classification models, random forest produced to the best overall performance, achieving 87.30% accuracy and 86.7% precision and 87% of recall and 86.8% F1 score. This demonstrates its strong ability to accurately detect fraudulent transactions while maintaining balanced performance across all evaluation metrics. Up next, for the clustering models, we use the silhouette score to measure cluster quality. dbScan achieved the highest score of 0.236, outperforming k-means with 0.189 and Gaussian model 0.181. This indicates that dbScan performed the better clusters and was more effective in identifying hidden transaction patterns and potential fraud risk groups. Overall, random forest was selected as the best classification model, while dbScan was the most suitable clustering technique, providing the most valuable insights for fraud detection and original decision making.
Thank you, Shreya, for sharing the methodology of model building as well as evaluation and result. Moving on to our key findings, which is the value business insight that we can gain from our project. Our model has highlighted two crucial insights that have direct business implication. First, high transaction frequency proved to be a major red flag of fraud, especially when an account logs 9 or more transactions within a 24 hours window. Therefore, companies must implement real-time monitoring system to track high-frequency purchases as they happen and automatically flag or temporarily freeze transactions that exceed this predefined threshold. Second, we discovered that behavioral features are far stronger predictors of fraud than standard demographic data. How can this help the business implication? Modern fraud detection engines shouldn't waste processing power focusing heavily on static profile traits like age or location alone. Instead, they need to prioritize dynamic behavioral patterns like how a user interacts with the platform to spot anonymous fast. Moreover, let's talk about what are the challenges and limitations that we face during this project. So basically, we all know that not every model is perfect, and therefore, we must acknowledge a few key limitations in our studies. First, we face limited feature representation. Because the dataset didn't contain every possible variables, it directly impacted our prediction accuracy. As a result, this result might not generalize seamlessly to more complex or multi-layer fraud scenarios in the real world. Next, static analysis simply cannot keep up with evolving fraud behavior. Scammers change their tactics constantly, right? That's why there's a lot of scammers nowadays in every part of the world. Therefore, the key takeaway here is a model trained today will become outdated tomorrow. To remain effective, business must establish continuous pipelines to regularly update and retrain their detection models using the newest live transaction data. Now that we have evaluated on our group challenges as well as limitations that we have faced during the project, we have come up with two actionable recommendations for moving forward for the future project or future people. First, utilize real transaction data. To make models more practical for production, the organization should partner directly with financial institutions or e-commerce platforms to access live data. Crucially, this integration must strictly comply with global data privacy regulation like GDPR to protect user trust. Having said that, the second actionable recommendation is collect more behavioral features. This is to boost the predictive accuracy system should expand the depth of behavior tracking, especially incorporating metrics like customer login frequency and IP address, reputation scores. By shifting from profiles to dynamic, real time behavior monitoring, businesses can stay one step ahead of fraud. The analysis demonstrate that machine learning is promising approach for detecting fraudulent transaction, with random forest providing the best overall predictive performance. Additionally, implementing real-time fraud monitoring and periodically retraining the models will help ensure that the fraud detection system remains accurate and effective as fraud patterns evolves. By adopting this recommendation, organization can improve fraud detection accuracy, reduce financial losses, enhance customer trust, and support more informed, data-driven decision making. Whew, there you guys have it. Those are the study that all of us found for the retail fraud detection in this project. So now let's move on and hear what are each of the members' reflection on this project. All right, everyone. Now that you have heard on our group project on the retail fraud detection, now let's hear from all of our reflections. So I will start from my reflection first. On the technical side of this project, I was under the hood of writing the Python script and driving the results analysis. And I'm glad that it's done now. That meant testing and building out models using everything from logistic regressions and decision tree to random forest. Now, the trickiest part of the process was dealing with sneaky, complex fraud patterns. We saw things like sudden device and location mismatch happening alongside rapid fire, high frequency purchases. Basic models just couldn't catch those multi layer tricks. To solve this, I have turned to assemble models like random forest. They were the real game changer, allowing us to capture those tricky nonlinear relationships in the data that standard models miss completely. To wrap it up, working with this team was an absolute breeze. I have loved cooperating with each and every one of them because all of us have been working on this project together. all of us have been sweating all of our blood, sweat, and tears into this project. But finally, it's done. Everyone pulled their weight, executed their part seamlessly, and made the whole experience awesome. And to be honest, I would love to work with them in the future project. Thank you. That's from my reflection.
Finally, here comes my reflection. For this project, I was responsible for the model building and evaluation section of both the report and presentation slides. I was able to learn a lot on machine learning models including logistic regression, decision tree, random forest, k-means, dbScan, Gaussian model using Python, and able to gain a lot of insights on it. Through this project, I learned how to use Python libraries to build machine learning models, create pre-processing pipelines, and evaluate model performance using metrics like accuracy, precision, recall, F1 score, and Silhouette score. These were new concepts that helped me better understand how different algorithms work in detecting frauds. One challenge I faced was selecting appropriate model parameters, especially for clustering algorithms, while another was interpreting and comparing the evaluation results across different models. I addressed these challenges by experimenting with different parameter values and researching the algorithms and comparing them with performances before selecting the most suitable one. Overall, I really enjoyed the subject because it helped me to strengthen both my technical and analytical skills. I also appreciate working with my fellow teammates as everyone communicated well, shared responsibilities, and supported one another throughout the project, making the experience overall enjoyable and successful. Thank you.
My contribution to this project was preparing the data mining approach and data preprocessing section. I researched the methodology, explained the data mining process, and described how the dataset was cleaned and transformed before model development. Through this project, I have learned the importance of data preprocessing and also how techniques such as standard scale, one-hot encoding, and also EDA improve machine learning performance. One challenge I faced was understand the pre-processing method and also select the most suitable technique. I overcome this by referring to academic source and discuss with my teammates. Overall, the project improved my teamwork communication and also proven soft skill. We are working toward a common goal.
For my contribution to this project, I worked on writing the report content, specifically drafting the introduction, data description, and conclusion, as well as creating and designing our presentation slides. So, throughout this project, I gained a much deeper understanding of how data mining can be applied to solve real world retail business problems, including the key contributing factors, business impacts, and practical solutions. So one of the main challenges though I faced was determining which dataset variables were actually the most predictive of fraud. It needed careful analysis, testing, and a solid understanding of the underlying data to separate signal from noise. Looking back, if we were to refine this further, I would recommend adding more and more interactive visual dashboards to enhance clarity and make the insights even easier to digest. Finally, I'd like to highlight that our team worked brilliantly together. Everyone contributed fairly, communication was consistent, and that seamless collaboration made working on this project a fantastic experience.
And that's all. That's the presentation from us, the Group D. Thank you so much, everyone. And thank you, sir, for staying tuned until the end of the presentation. And I hope you guys enjoy our presentation and learn some valuable lesson from us in this project. So thank you so much. And I hope you guys have a wonderful day ahead. Bye bye.